Make it good. What? Yeah? Oh yeah, we're doing a tutorial. Yeah, for sure. For sure. Okay. Let's continue. So, guys, come on. We're starting now. Starting now. Is this the next one, isn't it? Yeah, it is. Linear and quadratic inequalities. Okay? Yeah. Tutorial. The only hint I'll give you, okay, my hint is the answer becomes clearer if you use the factorizing method.
I did.
Ah, and it's not clear?
I don't know, I didn't like it.
Okay, tutorial then. Tutorial. Alright, so, inequalities. The first thing now is, what exactly do I mean by the word inequality? So that deals with problems like, with these symbols. Yeah. So problems with inequalities deal with problems involving these symbols. So they're not very different to what we've done so far, but there is a couple of things just to be mindful of. So before we get started with actual problems, just some of the things to be mindful of. So, for example, if you had something like A plus B less than C, then you're perfectly allowed to say A is less than C minus B. That's totally fine. And also, you know, if you had A minus B less than C, you're perfectly fine to say that A is less than C plus B. Okay? So there's no problem here and here. But there is one situation where we have to be careful. And that's if you had something like CD, well, I'll stick with my A and my B. AB is less than C. Okay? We can't necessarily say B is less than C over A. Like we can't automatically do that. In fact, there's only one situation in which we can do that. Yeah, what exactly needs to be positive? Well, something, you know, he's right, something needs to be positive. What needs to be positive? Which letter has to be positive to be allowed to do this? The A. The A has to be positive. In fact, if it was negative, it flips it around, yeah. So like for example, if you had x, minus 2x is less than 3, then that would get changed into x is bigger than minus 3 over 2. If you had 2x is less than 3, then that would get changed into x is less than 3 over 2. So when you multiply or divide by a minus, the sign gets flipped. But if it's a positive, then there's nothing to do. Stays the same, yeah?
So the addition and subtraction?
Yeah, the addition and subtraction you're free to do regardless if it's positive or negative. It's only for the multiplication and the division. Okay? So just take care when you are multiplying or dividing by negatives. Okay, so just take care when multiplying or dividing by negatives. You just need to be careful with that one. But other than that, it's more or less the same as solving regular equations. So we'll have a look at some examples now in a moment. Can I scroll down? I see people writing. Got this? Yeah? Yeah? Okay. So just before we actually have a look at examples, just some definitions here. This letter or here represents, I'm sure somebody knows what it represents. No, not actually. It's a set, if that helps. It's all real numbers. So, every real number belongs to this set. You know, so you can say 2 belongs to the real numbers, square root 2 belongs to the real numbers, you know, minus 3/4 belongs to the real numbers. Contains, as far as we're concerned, it contains everything. Okay, so real numbers contains everything. Okay, this next one here, does anyone know what this one's called? Yeah. Integers. And what is in this one?
Negative.
Negative, positive what though?
Whole number?
Yeah, that's it, very good. So it's negative and positive whole numbers like -2, -1, 0, 1, 2, etc. Yeah. What is this one? The Q. Does anyone know this one? It's called rational. Yeah. Oh, not quite the right word. Nearly.
Everything except the root. No?
No. I think you nearly have it.
Yeah.
Different word. Nearly like this. No. No. This one contains all the fractions. So it contains all the numbers that look like this. A whole number divided by a whole number. Yeah. Where these are whole numbers. Yeah. Okay. This one here? Not imaginary? Natural. And what does it contain?
Or positive number.
Yeah, and what about 0? In or out?
Oh,
So 0 we're not sure about. 1, 2, 3. No, what do we think? Is 0 in or out?
out.
It doesn't matter whatever answer you said is wrong because it depends on which book you're using. So some books include it and some books don't include it. So the way to help distinguish, if you want to be clear to the reader that you're including 0, what's normal I think is you put a little 0 here. That means you're including 0. And a star, very good. And if you want to exclude 0, you put a star. Okay, so this one here, 0 is in it. And this one here, 0 is out. Because this one actually, it really does depend on what book you're using. It's not clear if the 0 is in it or not. So I don't know, I can't remember if you were to look in a GCSE or an AS or an A-level book. I don't honestly remember if the 0 is included or not. You don't think so? Let me see, I can't remember. I thought it was, but it doesn't matter because we can make it clear by either writing a 0 or a star. Yeah. Okay, just a couple of more sets to look at before we can have a look at some questions. Can I scroll down a bit more? Yeah. You have all of these? I'm sure you actually maybe have seen them all before. Not yet. No. The time isn't ready for that. Yeah. But you are correct. There is another one. Yeah. Okay. Does anybody know the meaning of this set? You write bracket, thank you. A comma B square bracket. From A to B, including A and B. Yeah. So this represents, basically it's all the numbers between A and B. So for example, if I wrote 0 to 10, then in that would be 1, 0 would be 3.5, 10, 5, all the numbers, including decimals, 5.1, 5.2, everything between 0 and 10. So what's the difference between that and this then? I mean, they look the same. Yeah, that's it, excluding A and B. So that would be everything between A and B, but not A and B itself. And finally, you can even mix them. So this would be including A, excluding B. And just a little bit of vocabulary. The square one we call closed end, and this side we call open end. Okay, so this one we could describe it as closed at both ends, open at both ends, closed at the lower end, open at the upper end. We can describe it like this. Okay, so now that we have some basic terms, we can have a look at some examples. Okay. Can I continue? Yeah? Scroll down? So, right, here's our first example. So I tell you, that's an easy one to get started with. I tell you x is real, and I ask you to solve 6x plus 8 is less than or equal to 8x minus 6. So it's actually just like a linear problem. We'll take, minus, what did I say? 6. I'm going to take the 6x to the right, and I'm going to take the 6 to the left. So that one came over to the left, and the 6x went over to the right. Yeah? So that's a 2x, and that's a 14. So we can see that x has to be bigger than or equal to 7. Now you might be wondering, would I get the same answer if I did it the other way around? And you would. So for example, if I had 6x plus 8 less than or equal to 8x minus 6, if I took the 8x to the left and the 8 to the right, let's see what would happen. So I'd have 6x minus 8x is less than or equal to, what's that, minus 6 minus 8. So that's minus 2x is less than or equal to minus 14. So because we divide by minus 2, this guy gets flipped around. And that actually is the same thing as that. You see, here we're saying x is bigger than or equal to 7, and here we're saying x is bigger than or equal to 7 as well. It's the same thing. So it is the same answer. Now, sometimes in the exam you have to be a little bit careful. Sometimes they're a bit sneaky in the exam, and they say, give your answer as a set. So how would you write this as a set? Well, it's closed at 7, and its x is bigger than or equal to 7, so where do I stop? Infinity, yeah. Now think very carefully. Is it open or closed here? It's plus, yeah, as well.
Open.
Open.
Because
Yeah, correct, yeah. Yeah, that's it, yeah. Yeah. And the other thing you have to be careful about in the exam, sometimes they ask you to give your answer on a number line. So here, this is our line. It goes to infinity, goes to minus infinity. There's 0, 1, 2, 3, 4, 5, 6, 7. And the way you represent closed is you put in a dark circle, shaded circle. And if you want it open, yeah, like this. So here it's 7 to infinity, so like that. Yeah. Well, this one is closed because it's including 7. So you see, it's bigger than or equal to 7. That's what closed means. And what would I have to have here for it to be open? What do I need to say? Greater than 7. It's open.
And the only reason why we're not closing the end is because it's infinity, right?
Yeah, you never close on infinity. Because infinity isn't a number you can use.
And why is it infinity again?
Oh, because x is bigger than 7, so there's no limit. It's from 7 upwards.
So like it was x number at the behind and a number.
Yeah, then it would be a clause with the two numbers, which we'll do an example maybe in a moment. Yeah, did we write this down? Next example? Okay. So the next one, there's two ways to do it, and I'll show you both ways. So firstly, just to say x is an integer, and we have minus 11 less than or equal to minus 2x minus 17 less than or equal to 5. I think I got that. Now, so this one's very interesting because it's a double inequality. You have this thing here must be bigger than minus 11, but it must be also less than or equal to 5. So it's bounded between these two ends. So there's two ways to do it. The first way is maybe what you might think is the most natural way to do it, which is just to split it into two separate problems. So minus 11 is smaller than or equal to minus 2x minus 17. And is it and or? Yeah. And, yeah, very good. And minus 2x minus 17 is less than or equal to 5. And then we just solve each of them separately. So this would be, what would that be? 17 minus 11 less than or equal to minus 2x, yeah? 6 less than or equal to minus 2x. So minus 3 flipped around. So x is smaller than minus 3, or equal to minus 3. And minus 2x is less than or equal to 5 plus 17. Minus 2x is less than or equal to 22. X is bigger than or equal to minus 11. Now, the and is important because we need to put both answers together. So, it'll be helpful to imagine a number line here. So there's 0, there's minus infinity, there's minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So, here is the red one. X is smaller than or equal to minus 3. So that's here to the left. Now, in blue, x is bigger than or equal to minus 11. So wherever minus 11 is, like here to the right. Now, because we want and, there's only one part of the number line that can give me both.
The overlap.
The overlap, yeah. So the minus 11 to minus 3. However, there's one extra consideration. Yeah, at the very start I said x is an integer. Yeah, so how would that affect my answer? So this is not quite right just yet. Because remember, minus 11 to minus 3 includes every number, like 10 and a half, 5 and a half, 1 and a quarter, well not 1 and a quarter, 3 and a quarter, but it must be an integer. So my answer is not quite this. It's not every number between minus 11 and minus 3. What is it exactly? Which numbers? Whole numbers between minus 11 and minus 3. So that means the answer is this. Minus 11 or minus 10 or minus 9, etc. all the way up to minus 3. And this is the actual answer. All whole numbers between minus 11 and minus 3, including minus 11 and minus 3. Okay, so write this one down, and I said there's a second way to do it. So why people are writing I wonder if anybody knows the other way. Yeah, you think you know it?
You just do it at the same time. Just you want to add by 17, you do it.
Yeah, you make all the changes happen to everything at once then. Yeah, you've seen this one before. I'll just squeeze it in here. Minus 11 less than or equal to minus 2x minus 17 less than or equal to minus 5. So what I do, I want to get rid of the minus 17. So what do I need to add to everything? Yeah, to both sides, yeah. So what do I add to both sides? 17, yeah. So if I add 17 to both sides, I get 6, cancelling, and 22. Oh, not bad. Now I want to get rid of the minus 2, so what do I do? To both sides I divide by minus 2. Yeah, but because it's minus it gets flipped. This is exactly the same answer as this.
Minus 3.
Oh, sorry, minus 3 there. So it's all the numbers between minus 11 and minus 3, but once again, we need to remember that we're only looking at whole numbers, so we get the same answer. So this is much easier to be doing, right? Much easier. And this is usually what they expect the student to do in the exam, so if you can write that down, that would be great. Okay, what we're going to do now in a moment is a quadratic, because you realise all the examples we've done so far are only linear. So we need to have a look at a quadratic now. Scroll down? No. Good. Okay, so with the quadratics, it's a little bit different, but there's two ways to do the quadratics. So let's have a look. Scroll down. Okay. Let's say x is a real number, and minus 7x squared minus 41x minus 63 is less than or equal to minus x squared. I will start by taking everything to the right. So I have 6x squared plus 41x plus 63. Can I divide by anything? Can I?
No.
No, I can't. Okay.
Factorize it.
But I can factorize it. So anyways, you don't have to factorize it. The way you continue is by solving it. You need to figure out the two roots here. So you could just use your calculator if you want, because the next step here is to draw a quick graph. So graph and calculator will power through and tell me the... No, graphing's not necessary, thank you. Or I have a Casio 991, mode 53 I think does it. Yeah.
You want the factors?
Factors or roots, what have we got?
2x plus 9.
2x plus 9, so minus 9 over 2, yeah.
And 3x plus 7.
So minus 7 over 3. So there's one here at minus 9 over 2, and one here at minus 7 over 3. And is it a U or a hill?
U.
It's a U shape. Now this is how you think about it, okay? You imagine that this is equal to y. You're looking for the part of the graph that is bigger than or equal to 0. So that's either going to be here and here, or here. So I hope you can see that it's this part, because this is the part that's above, that is more than or equal to 0. Yeah, it's touching on what we did in the cubics as well, yeah. So, because I want this and this, my answer is everything up, minus infinity up to this, and then this one here to infinity then. Here? No, I think this goes all the way up to infinity. Yeah. I wouldn't say there's a minimum.
You'll be asking to express
There's a
it.
minimum and maximum.
Are you supposed to leave the answer like this, or are you supposed to write
No, well, they would want your answer written either like this,
And
or if you want to give your answer as a set, they would take it like this. Minus infinity to minus 9 over 2, open or closed?
close.
Closed. And then this one here, minus 7 over 3 to
Positive
infinity, yeah. Open or close? Oh, sorry. Open here, close here. And what symbol goes between them? Yeah. Not quite plus, but I know what you mean. Union. Which is like a plus. It means you consider the two together. So that one is there, and that one is there. Now, if I asked you for less than or equal to 0, what would your answer be?
between the
Yeah, between them. The answer would be bigger than minus 9 over 2 and smaller than minus 7 over 3. But that's if I asked you for the other one, less than 0. Yeah? Now, I said there's two ways to do this one, so I want to show you the other way. Even though I think this is probably the best way to do it because it's the quickest. Because really all you're doing is making a very quick graph. And then once you sketch the graph, you have the answers immediately. But let's have a look at the other way to do it, which is a little bit more formal. Let me see. I'll zoom out a little bit and just write it over here. So we have minus 7x squared minus 41x minus 63 less than or equal to minus x squared. So likewise, just like before, we can get 6x squared plus 41x plus 63 greater than or equal to 0. But this is where it's a little bit different. You do actually look at the factors. So what's that? 2x plus 9 factor, and then 3x plus 7. And you think about it logically like this. I have two numbers which multiply to be a positive. There's only two possible pairs of numbers that can multiply to make a positive. The first possibility? Positive and positive. So just to be clear, maybe I should say positive and positive. Or, negative and negative. Now let's examine what each of those mean. So here, if I demand both of them to be positive, I need 2x plus 9 to be positive and 3x plus 7 to be positive. So that means I need x to be bigger than or equal to minus 9 over 2 and x must be bigger than or equal to minus 7 over 3. Now the and is very important here. If x has to be bigger than minus 9 over 2 and bigger than minus 7 over 3, there's only one way it can be both at the same time. Can anybody see what way that is? How could a number be bigger than minus 9 over 2 and bigger than minus 7 over 3 at the same time? Yeah, when it's bigger than minus 7 over 3. You know, if I said to you, a number has to be bigger than 5 and it has to be bigger than 7, then it means it has to be bigger than 7. It's the only possibility, you know. If a number is bigger than 10 and it has to be bigger than 20, then it means it has to be bigger than 20. So you just need to look at the bigger of the two. So you get x is bigger than or equal to minus 7 over 3. Right, let's go over to the negative side. 2x plus 9 needs to be negative and 3x plus 7 needs to be negative. So that means x must be less than or equal to minus 9 over 2, and x must be smaller than or equal to minus 7 over 3. So again, let's think of the negatives, okay? If I say a number has to be smaller than 5, and it has to be smaller than 3, then it has to be smaller than what?
Negative 1 over 2.
No, I'm just on my 5.3, for example. So if it's smaller than 5 and smaller than 3, it has to be smaller than 3. It has to be smaller than the smaller of the two. So if it's smaller than minus 9 over 2 and smaller than minus 7 over 3, smaller than the 9 over 2, yeah. Now what word is between these, and or? No, remember, it was or to begin with, so it's or here. But you realise that's exactly the same answer that I got here, but just a lot more work. A lot more work, that's the only difference. So this is the way I would like you to do it in the exam, obviously. Much less effort. Well, I mean, if you want to do it the harder way. No, I know this. Nobody does. Okay, so if we can write this one down, please. Got it? Yeah, it's essentially the same. Basically, the graph on the left is doing a lot of the work that the algebra on the right is doing. Okay, we got that. Right, last example. And don't worry, if you found this too easy, I saved the most difficult one until the end. Okay, so the last one here. X is a natural number including 0. So 30 less than or equal to x squared plus 10x plus 30 less than or equal to 69. Right, so what can we do here? We can't, we'll have to factorize it. Well, actually not just yet. We can't do the same trick we did before. We can't. It's not possible for these ones. It doesn't work out as nicely. Yeah. Well, you see what happens if you did minus the 30, you'd be left with x squared plus 10x. In the previous method, you were trying to whittle it down to just an x. It's not something you can really do here. Yeah, you'll have to split it. So, let's separate it into two. So 30 less than or equal to x squared plus 10x plus 30, and x squared plus 10x plus 30 less than or equal to 69. You can use the symbol, that's fine, yeah. Okay. 0 less than or equal to x squared plus 10x. Now this quadratic ain't so bad. What's its two solutions?
0 and
Yeah, the roots are
0 and minus
0 and what's the other one? Minus 10, isn't it? Now, do I want to be above or below this quadratic? Above it or below it? Above. So, that's here and here. Okay, so that is x is less than or equal to minus 10, comma, x is bigger than or equal to 0. The left one and the right one. Okay?
So you would have 4 things here?
Yeah, and we'll have to combine these at the end then, yeah. So here, this is x squared plus 10x, what's that? Minus 39, isn't it? Yeah? 30 minus 69 is minus 39?
yeah.
Right, what are the solutions here? It's like 10 and, not 10 and 3. No, 13 and 3. 13 and 3. Is it minus 13 and plus 3?
No.
Plus 13 and minus 2.
Yeah, but the roots.
3 and negative.
That's what I was saying, yeah. 3 and...
X minus 3. X minus 3.
X plus 13.
Yeah. So you're right. So
This is right.
negative 13. Yeah.
Because the factor is x plus 13.
Yeah.
Okay. Right. Now, do I want above or below here? Below, yeah. Because?
Less than
Well, because it's less than 0. Yeah. So x must be bigger than minus 13, but smaller than 3. Now, remember, there's a big and here. We have to combine these answers together. So, on a number line, let's mark off the key numbers. 0, no.
Can't be minus.
Yeah, we have to get to that in a second. 0, 1, 2, 3, 4, off we go. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. Right, so in red we have x must be bigger than or equal to 0. So that's closed and here. And then minus 10, left or right? Left. And in purple, between 3 and minus 13. So when do I have both red and purple?
13 to minus 10.
Yeah, minus 13, minus 10, and 0, 3. So, for the moment, it looks like you're saying the answer is minus 13, minus 10, union 0, 4. Oh, sorry, 0, 3. But we have to remember something I told you about x at the beginning. What did I say x was at the beginning? Natural numbers, which means straight away that one's gone. And in fact, I don't even include 0, 3 like this, because I only include whole numbers. So what whole numbers do I include?
0, 1, 2, 3.
Now, do I include 0? I do. So my answer is 0, 1, 2, 3. So if you were to choose any number, 0, 1, 2, 3, and you put it into this quadratic, you will get a number which is between 30 and 69. So 0, 1, 2, 3 are the 4 possible answers here. Okay, so if you can finish writing this one down. Now you see, the thing with these questions is, there's not a lot to write down there, but there is a lot to think about. An awful lot to think about. Okay, do you have this written down? Yeah, this one is at the 39-minute mark. Okay, did you write this down? Yeah? Got this? I can close it? Yes, I take it as a yes. Okay, try these for a few minutes. We'll stick with tradition, first and last. So AZ, AZ, AX, AT. Yeah, that's fine, yeah.